Hello and welcome to Cairo Academy. My name is Okoli Evans. So today we are going to take a look at data types in Cairo language. So normally most languages have data types. Basically all languages have data types, and sometimes most of these data types are similar across all the languages here. So if, for instance, if in JavaScript you have something like integer, boolean, felt is not that popular among other languages, but then across most languages we have similar data types. But then when you come to Cairo, so in Cairo the data types are categorized into two. We have the scalar data types and we have the compound data types. So scalar data types deals with a single value types. So you have things like felt 252, you have integers, you have booleans, and also maybe strings. Yeah, so we now look at this one after the other. Yeah. So let's open up a project on VS Code. Okay, so do scab new. Okay, let's call it data. So data types. Okay. Let's just ignore the error. Continue. Seed into the new project. That's data types. And then open on VS Code. Okay. So let's first of all add a StackNet version. StackNet is equal to, we are using 2.8.0. Yeah. So go into the source folder, clear this out. Okay, so let's create data types dot Cairo. So now we add the new file to this lib.cairo file. Do mod data types. By now we should be conversant with all these ones. Now we have our main function. So now we can create other functions and practice what we want to do, and then we can call all of them from the main function. So I'm just trying to explain, because most of these things are what you have seen already in the previous videos. So my advice is, if you have not been following, you can just maybe go back to the previous videos and start from them. So you have a function here. Let's look at felt type. Felt 252 type. So felt 252 is just short string. So is that 1-bit string. You can't use more than that 1 bit of letters in felt 252. And another thing about felt is not most, if you do not pass a specific data type to your variable, the Cairo compiler is going to automatically assign felt 252 to it. So this becomes significant when you're working with maybe numbers, because when you start doing operations and other stuffs, what you'll be getting will be like, it will not be correct. Like, it will be abnormal or arbitrarily large numbers compared to what you would have gotten if you specify a data type. So I'm going to show you in a few seconds. So let's have this. Let's name to pass the type. You just put a colon and then what you have is felt 252 like this. So you can just pass a single quotation like this. So name can just be this. This works. So this is basically how to use felt in Cairo. You can just pass a short string less than 31 bits. So this works. But when you have something like let's fast, okay, let statement of type felt as felt 252 is equal to a Cairo developer from Lagos, Nigeria. So let's see the error message you are getting. So it says the value does not fit within the range of 252 type. So the reason is this is more than 31 bits already. So that's why I said felt is just for short strings that are less than 31 bits. Yeah, so you can just do with this. Okay. So that's for felt type. Let's look at integers. Integer type. So integers are just numbers. Yeah, if you're used to, maybe if you have tried other programming languages, is the same. So it's integer is numbers everywhere. But in Cairo we have signed integer and unsigned integer. So signed integer is a number that can be negative. So you can have -5 or -10. That's a signed integer because it has a negative sign. But unsigned integers, they don't have signs. It's only positive. You can't have a negative number as an unsigned integer. Yeah, so let's look at signed integers. So say let x. So signed integers in Cairo ranges from I8 to I128. So you have I8 is the lowest range. Then you have I128, which is like a very large number. So this is the range that you can use a signed integer. That's I integers in Cairo. So I have that I8 is equal to maybe 40, something like this works. Yeah. So when you have something like 400, it should throw an error because it's outside the range of 8 bits. I think 8 bits and around 8 bits within the range of 0 to 255 characters. So yeah, I also have to know the range of the particular type you are using. Like if you're using I8 is within 0 to 255, and then as I increasing the range, the numbers, the limits are also increasing. So yeah, this works. And then let's do let y of type I8 is equal to 60. So what I want to, let me show you the first thing about integers. So about not only integers, about integers. You cannot have okay, let's do I32 here. It works, but when you want to do operation, like let's see something like let sum is equal to x plus y. you're supposed to get an error here. It says unexpected argument type. It's expecting I8, but we are passing I32. So that tells you that you, in terms of mathematical operations using your integers, the two types that you are comparing must be, the two variables must be of the same type. So the two variables here, x and y, must be of the same type. Yeah, so if not, it is going to throw an error. So that's that. So I can just convert this back to I32. And then let's print this and see. We say sum is, and do sum and before, and then let's, yeah, okay, cool. Now we call the function in the main so that you can have access to it. So let's run this and see what we get. Oh, that was a mistake. So have scap, oh, scap build. Okay, fine. Now do scap Cairo run to run the program. Let's see what we get. It should give us 100 exactly. So this gives us 100 is correct. So pay attention. I want to try something else. Let's say we did not add the type to this. So we did not specify the types we are working with. The compiler is seeing this now as 3252. So that's the problem. That's the issue we have when you don't specify your data type. It's going to, like, compiler is going to pass a default type of 252 to all your variables if you do not specify the data type. So I think this should also work. It should also work. Let's see. Oh, okay, yeah. So it works. It works. Okay, let's do sub. So I want us to look at something. I want us to look at something. Let's pay attention to this. Okay, let's see the value we are getting here. Can you look at this? I mentioned before that sometimes if you do not specify the data type, compiler first of all will see it as a failed type by default. So now what is happening here is that compiler is working on these numbers as failed values, not as integers. So that's why you are getting this very large number here. That's the reason I mentioned that it's important to pass your data types, especially if you're working with numbers. So yeah, so let's return this to I32. I32. Okay. Okay, let's clear this. And run again. So see what we are getting now, because we passed the type here as a signed integer. We pass the type as integer here. We are now getting a reasonable number compared to the number we got before. So now this is the correct uh, result for this mathematical function. So this is basically how you work with your integers. So I'm going to also show us one last trick, or maybe it's not a trick per se. Let's just look at this. So I changed the type from a signed integer to unsigned integer. Now let's see what happens. Let's watch and see. So we are getting an error. What are we getting? That the program panicked. So the error message is underflow. We are getting an underflow error. Why? Because I mentioned earlier that unsigned integer cannot have a negative sign. So the result is supposed to be -20 here. But because we are now using unsigned integer, this cannot work. It returns an error here. So that's an underflow for you. So you now have the like the details, the full details. If you are working with, maybe you are building a DeFi application, or you are working with numbers, do not use a signed integer for your DeFi applications if you are working with maybe currencies or money, because of this issue. If you use a signed integer, it's not going to check this error for you. So you are going to run into bugs. But if you are using unsigned integer, it's going to have all these checks in place for you. Yeah, so that's that on integers. So I think we also have a boolean type. So let's look at boolean type. So boolean types return either true or false depending on the condition you are working with. So yeah, they are mostly used in conditional statements when you are working with maybe if statement, or if then, if let, all those conditional statements. So depending on the condition, it either returns true or false. So let's look at an example. Let is logged in. Oh, let's use the let is logged in of type true is equal to, let's do false. So this is a Boolean statement. In Cairo now, the compiler can infer that, okay, we are working with a particular data type without you having to pass the data type explicitly. So what I mean by that is, if I remove this Boolean here, the compiler still recognizes this as a Boolean type. You can see it here, type bool. So this is because I passed the condition false here. So compiler still sees it as a Boolean type, even if you do not pass the type explicitly. So yeah, that's, but I like passing this just to be sure of what we are working with. So we can now have a condition that if it's logged in, if it's logged in, print logged in. Like you get the flow. It's just the normal where you use your if statement and everything. So boolean type is just working on maybe assertions or conditions, true or false, 1 and 0. That's basically it. So if it's not logged in, print not signed in. So let's call this from here. Boolean type, comment this out, figure this out. Okay, let's I don't know if this is bold enough, so let me just increase it. So we are working with the boolean type. Yeah, so let's now run this. So we are getting not signed in. Why? Because I set this as false. Excuse me. So what this basically means is this user is not logged in because I set it as false here. So he's not logged in. That's why we are getting not signed in. So assuming I convert this, I change it to true, you're going to get you're going to get logged in as an output. So this gives the program conditions to work with depending on the so we are getting logged in. So depending on the depending on the condition, we are either getting logged in or not signed in. Compiler is working based on the condition we pass. So that's basically what boolean type is. So that's that about boolean type. We now look at byte array. Byte array type. So oh no, not yeah. So byte arrays are new updates on Cairo language. So these are used for longer strings. You know, I mentioned that 3252 is used for strings that are less than 31 bits. But if you have longer strings like text, statements, longer, maybe a list of stuff, so you can just use byte arrays. Yeah, that's what we use for long strings. So let's say an example. Let's statement. What am I typing? Statement of type byte array is equal to. So this uses double quotation. It is double quotes like this. So byte arrays use double quotes, not single quotes. Fed uses single quote. Byte array uses double quote, and then you can have a very long statement. Something like maybe I have remember, if I'm correct, working with Cairo language. So you get the idea. I love Stacknet. You know, like you can have a very long text or anything that's string and it works perfectly okay. So that's byte array for you. That's byte array for you. So this is basically the scalar types we have in Cairo language. Yeah. So you have seen felt, integer, boolean, and byte array. So let's look at the compound types. So we have basically maybe two major or three major compound types in Cairo. We have tuples and arrays. So for the scope of this video, we are going to only look at tuples and fixed size arrays. We have fixed size arrays, we have dynamic size arrays. But for this one, we are going to just see tuples and fixed size arrays. So in the coming videos, we are going to like have a separate video to look at arrays in detail. So for now, let's just uh, tuple type. So the way tuple works is the same way it works in other languages too. So you can just create your tuple, with maybe different types or the same types if you like, and then you can destructure and use it in your program. So let's see, let's let items, you must specify the types. So we can have 2 or 3 or 10, any amount you want. But let me just stick to maybe unsigned integer 32. We use felt 252. Sorry, we are passing the type now, not the values. And then we have maybe a boolean. It's equal to okay, 252, maybe 50. Hello. It falls like this. So yeah, this is me defining a tuple. So you have your types. We are working with type unsigned integer of 32 bits. You are passing for 252 and boolean. So that's why you have this here. This is for 252. This is boolean. So let's structure this. X, Y, Z is equal to items. Yeah, exactly. So now you can now work with these tuple elements individually. You can choose to work with X, with Y, or with Z. So you can now say maybe, okay, if let's try something else. Assert that X is equal to what? Is equal to 50. Incorrect assertion. I think this should go. Let's call this from the main. Says tuple type. Yeah, I think it's supposed to work. Let's just run it and see. Okay, so we have that this is correct, because if not, it's supposed to throw an error that assertion is not correct or assertion failed. But then since this pass, that means this is correct. So this is the way you work with tuples. Yeah. So we look at fixed size arrays, fixed size arrays. So if you're working with a fixed, maybe a constant collection of stuffs, or maybe something like days of the week or months of the year, since these things are constant and they doesn't change, you can use fixed size arrays for them. If you are working with a fixed list of maybe members of a club that you are not expecting the list to change anytime soon or even change at all, then you can use fixed size arrays. So fixed size arrays are used in programs when you know that, okay, the list is not going to change at all after you deploy your programs. So that's why I say, okay, if you're working with maybe days of the week or months of the year, is okay to use fixed size arrays. So yeah, can now have array. So is okay. Let's just continue because you can specify the data type you want and also the length of the array members, like the array elements. So the way to do this is have this so the way this works is to pass the data type. So let's work with byte arrays. Oh. And then pass the number of elements you are going to work with. So let's work with maybe days of the week, which is 7 in number. So Monday to Sunday. You can just pass 7 here because you have 7 days in a week. So let's just now fill the array with the days of the week. Oh, sorry, that should be Monday, not Mondays. So we already know that if we are using byte array, it has to be double quotation marks. So if it's failed to 252, it's single quote, but if it's byte array, it's double quote. That's why we are having double quotes. So we have I don't even need to. We can just do this is Thursday. You just use shorts. This is Friday. Saturday. Sunday. Okay, so this is our array containing the days of the week. So now, one way we can use this array is just to destructure it. So when we destructure, you can now pick out any day of the week that you want to work with. So let's have maybe let's work with Wednesday. The trick here is if I don't need to work with Monday and Tuesday, I can just represent them with underscore instead of just maybe passing a variable to hold them. Since I don't need them in my program, I can just use underscore to represent them. So Monday underscore, Tuesday underscore. Then maybe we need to work with Wednesday, so you can just maybe give it A, or maybe maybe C. Since A and B are represented as underscores. So Thursday, Friday, Saturday, Sunday is equal to this array. Can this work? Oh, okay, this works. This works. I think that was just the compiler trying to sort things out under the hood. So yeah, we have successfully destructured the array. So now these are the days, but then we don't need Monday, we don't need Tuesday, we don't need Thursday to Sunday. What we are just interested in is the Wednesday. So that's why we have C here to represent Wednesday. So if we want to work with maybe Saturday, we can just come here, maybe add F, abi C D E F. So here should be F. That means we now have access to work with Saturday. This. So we are working with now only this and this. So let's just maybe print the date to the console and see. So if we use print line, and then the day is C. So let's just say, okay, you want to pass the day to the CLI now. Like you want to use the day in your program. Probably you're not passing to the CLI, you are using it to maybe perform one or two functions in your program. So the way you pass it is just as a variable here, pass it here. So the compiler already knows the day, like the index of this in the array. So it's now going to be tracking that element using this index. So when we do save and run this, let's build. It's taking time. Okay. Now let's run this and see what happens. This is taking time. So unusual. It's just wait and see what happens. Okay, so yeah, today is Wednesday. Today is Wednesday because why? We passed, we are presenting this Wednesday with C here. So this C is tracking the index of Wednesday. Yeah. So that's that for fixed size arrays. So finally, let's look at type conversion in Cairo. So let's look at type conversion. In Cairo, you can convert from maybe float to numbers, that's to integer, either uint or int. So you use try into or into. So we see how to use it in a few seconds. But when you have maybe want to convert from a larger number to a smaller number, so you use try into, because try into is going to return an option for you. Like it's going to check, the conversion to see if the destination type is going to be enough to contain the type you want, the type you want to convert. So assuming you want to convert 500 on maybe U32 to U8, which contains only 255 values. On when you are writing the code, it's not going to throw error, but the compiler will tell you that okay, this is not possible because there's no way you can convert 500 to a value between 0 and 255. But then that's just how it works. So you use try into when you are not sure about the values you are passing. So if you are not sure that the destination value is smaller than the type you are passing it to, so you have to use try into. But if you are sure that okay, what you're passing is definitely smaller than the destination value, so if you are sure that maybe you want to pass U8 value to a U256 or U232, sorry, U32. So you are sure that okay, this U32 is obviously bigger than U8, so it's going to eventually convert. You can just use into it. It works like that. So let's see some example. So convert, function convert. So let's first use try into. So let x of u it is equal to 200. That should work. Yeah. Now have let y of u 32 is equal to 1000. That works. Now to convert to, let's try to convert this. Oh, okay. Let's try to convert this y to u8 and see what happens. So let's use try into. Now we select z of type u8. So we have to specify the destination type. The destination type is the type you want to convert to. So I'm converting u32 to u8. Now let's do is it's equal to y dot try. Okay, so this is not trying to dot unwrap. So this is the syntax to convert. So I want to convert this y that is 1000 to u8 that is between 0 and 255. So it's not going to work, but let's just build it and run the program and see. Okay, it's not supposed to run, like it's not supposed to work. Oh no, sorry. Let's comment this and then call that's a mistake. So let's call convert. So let's build it again. And now let's see what happens. Da 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 da. This, yes, so it's supposed to panic. Unwrap failed. So this u8 cannot contain this value. So there's no way it can convert from this to u8. That's why we are getting this unwrap failed. So you can also maybe use expect here. So expect is expecting maybe value cannot be converted. I think you're expecting failed to 252. So yeah, you can either use unwrap or use expect. Expect is going to have the error message that are going to pass. So it's maybe even more idiomatic in a way. Not idiomatic per se, but at least you are passing the error. So the user or someone that's going to run your program will say, okay, this is actually the reason why this is failing, because you pass the error message. So we have this. Let's try to run, see what we get. So instead of having the previous error, I think we had okay, what was the error anyway? Okay, so let's just ignore that. So instead of having the unwrap failed error that returned earlier, so if this is a big program, maybe you have a very big, large code base as the program, and we have multiple places that we are unwrapping. So you might get this error multiple places in multiple places, and now when I run this, I might not know the exact place that the error is coming from. But if I have all these custom messages, I can say, okay, now this is coming from this. So yeah, so we have this as the error message. But let's do something. Assuming we want to convert this to maybe U64. So we know that definitely U64 is bigger than U32. So let's try to convert. Let's see. Let's run and see. So successful. It did not panic. So now I mentioned earlier that if you have two values that, okay, I want to convert, maybe for instance, now that we are converting from U32 to U64, we are 100% sure that this can convert. So I don't think there's no need to have all this here. So we can just do this. This should work. So again, if you're 100% sure that the destination type you are converting to can accommodate this type that you are sending, like the type you are sending. If you are sure that U32 that we are sending, that's why is of type U32. So if we are sure that this can be accommodated in the destination type, our destination type now is 64. So we are sure that, okay, 32 can be accommodated in the U64 type. So instead of going through the route of doing try into dot unwrap and all those ones, you can just call dot into. So let's see what happens. Successful. So why? Because we are sure that this should work. Let us mean we return this back to maybe U8. Okay. It's already throwing error safe. So it's already giving us that this is not possible. Threat has no implementation in context. In the context where you are going to convert 32-bit integer to 8-bit integer, there's no implementation for that. So it is throwing error already. That means it cannot work. Yeah. So we are back to this. So you can also convert your 3252, your contract addresses to 3252 or to integers or to anything. So you just, the more you practice, I just say this is a simple guide. Videos and tutorials and maybe documentations are not supposed to teach you everything. They're supposed to act as a guide for you. So you, after learning, have to go and practice. So it's up for you now to take this up, practice more with it, try other different types, try to convert from maybe 3252 to integer or integer to 3252. Or you can also try to convert contract addresses to 3252 and see what happens. So you can use try into and see what the compiler gives you. You can also use into and see what you get. So that's basically how you learn. Yeah. So I think that will be all for this video. So please subscribe to the channel, give us a thumbs up and share with your friends. Thank you very much for watching and have a nice day.